Utilities are navigating one of the most complex and multifaceted transitions in their history.
The utilities sector faces the challenge of transforming operations while balancing efficiency, compliance, and customer expectations.
Definitely carbon reduction, definitely energy transition linked to that, different fuel sources. The rise of the prosumer is something else that I would call out there.
Raising the bar, raising expectations, and moving beyond simple condition monitoring toward more advanced solutions.
Managing 10 connections is very, very different to managing 1 million connections. And the platforms need to be architected to do that from the outset.
A very warm welcome to everyone joining this expert conversation on smart operations IoT for utilities. My name is Nathan Budd and I work within IDC's custom solutions team, and I will be your host over the next 20 minutes or so. Now, like several industries, the utilities sector faces the challenge of transforming operations while balancing efficiency, compliance, and customer expectations, all within an increasingly turbulent and uncertain macro environment. In utilities, this challenge is heightened further by the mounting pressure to balance decarbonisation, efficiency, with a core commitment to delivering safe, reliable, affordable, universal services, and at the same time delivering seamless digital services and efficiencies, electrification, and innovation to customers. And all of this requires the alignment of technology, processes, and people, often referred to as smart operations. An essential feature of this is the utilization of IoT to help manage, disperse networks of sensors, meters, and control systems, all in real time. But what is the role of IoT in such a distributed asset, and how is the demand on extended reach and low power being fulfilled? What are the connectivity options available? Is cellular IoT connectivity up to the task of meeting the demands of utilities? And what are some of the critical factors that utilities need to get right when it comes to IoT deployments? And to help us navigate those questions, I'm very pleased to welcome three special guests. From IDC's Energy Insights team, we have Jean-Francois Segalotto, Senior Associate Advisor. From IDC's IoT and Mobility team, I am pleased to welcome Research Director John Goll. And I'm also very pleased to welcome Andy Haig, who is Utility Sector Business Development Manager for Vodafone IoT. A very warm welcome to all of you. Thank you so much for joining. I think to kick things off, it makes sense to come back to some of the opening remarks. What are the core dynamics of the broader utilities market, Jean-Francois? What's driving this? What are the challenges? What are the priorities? What's going on?
Thanks, Nathan. Hello, everyone. I think your introduction said a lot already. Utilities are navigating one of the most complex and multifaceted transitions in their history, to use a maybe overly abused term. Multifaceted has been used a lot in the past several years in the industry. The industry is being reshaped by multiple forces. Decarbonization is one you mentioned, resource conservation is another, electrification, digitalization. On top of that, we have decentralization of energy systems, shifting demand and supply patterns, infrastructure obsolescence, and in many countries also a significant talent crunch utilities are faced with. Customer expectations are also evolving. Customers want transparency, control, sustainability, and this is pushing a welcome evolution in the utilities organizations. Utilities are pushed to act less like infrastructure operators and more like data-driven service organizations. So a long list of challenges, many or all happening at once. I think what's most relevant to our conversation today is the convergence of the physical and digital planes, or the physical and digital infrastructure. Many will say IT/OT integration, IT/OT convergence. That comes under many names. That convergence offers enormous opportunities to address all of those tech challenges, but it also forces utilities to kind of fundamentally rethink how they plan, how they operate, how they maintain their systems.
Really interesting. And John, you come to this from the IoT perspective. How is that related to some of the broader IoT strategies that you see within the utility sector?
Yeah, well, what we see across all industries actually is a keen interest in leveraging IoT technologies to achieve a wide range of purposes. They and utilities are certainly one of the industries that is really kind of leading the adoption. What we're seeing is that companies need to leverage a wide range of sensors for condition monitoring, but they're also raising the bar, raising expectations, and moving beyond simple condition monitoring toward more advanced solutions like predictive analytics, automation, and autonomous systems. And so that's true across most industries, but utilities certainly they're embracing use cases that leverage these IoT sensors for connected systems, for condition monitoring, and moving toward more advanced solutions to automate their widely distributed infrastructures in the utility space.
Fascinating. Andy, to bring it to you, I mean, we talked about turbulent macroeconomic environments. Jean-Francois talked about all of the priorities and things that are happening with utilities. When it comes to IoT, John is also outlining a lot of the things that are going on. I mean, complicated job that you've got there. How does this kind of inform the way you're approaching utilities, and how do you balance all the priorities?
So I do think Jean-Francois kind of nailed it there in terms of describing the things that are impacting all of the utilities at the moment. So definitely carbon reduction, definitely energy transition linked to that, different fuel sources. The rise of the prosumer is something else that I would call out there. So a much more dynamic energy network than was maybe envisaged only 20 or so years ago. I think the other thing that I'd throw in there, aside from geopolitics, which is obviously challenging for everybody with different fuel mixes becoming more or less economic as we work through those, is the emergence of AI into almost every conversation, and I'm unapologetically going to introduce it into this one as well. And that's having a real impact on IoT in terms of us seeing AI as a component of almost every system, whether that's in the core or at the edge. One other point that I'd make to pick up on John's intro as well is the absolutely, you've got the sort of network sensorization activities that are taking place within the utility sector. You've got a huge amount of activity as well in what we would call our edge energy component. So this would be things like solar farms, the prosumers with solar that we've just talked about there, EV charging, battery storage systems of various sizes. All of these things are having a real impact beyond what utilities would previously have called the edge of their network. But taking it all a stage further, we're also seeing, and a lot of it links to talent, attracting new talent, and maintaining the workforce within utilities. IoT taking place beyond actually pure network devices. So we're seeing the workforce management applications and workforce safety applications as well being a really burgeoning sector for us within the utilities domain, right the way across all of the all of the fuel types and the utility sources.
Fantastic, thank you. We were doing so well without mentioning AI, Andy, but it's very much the
I'm sorry,
elephant in the
I'm
room,
sorry.
and particularly when we're talking about such rich and complex data sets.
Was there a sweepstake?
So to bring it back to smart operations, the kind of central focus of what we want to talk to today, I suppose the question really needs to be asked, Jean-Francois, what do we mean by smart operations? What's the role of that and importance of that to utilities?
Yeah, I think the definition of sorts is warranted at this point. So smart operations, again, to use an overly abused expression, is, I would say, literally putting data to work or putting data at the center of how utilities run their businesses. In simple terms, it's the progressive shift from reactive and manual processes to proactive, data-driven, and increasingly autonomous operations wherever applicable and safe. Of course, it's not just about connecting assets. That's the easy part, and utilities have been doing that for decades, even before IoT was actually called IoT, or even machine-to-machine communication. It's about using data to make those assets, and more of them actually, as utilities asset bases continue to expand, more observable, more controllable, and more adaptive or flexible, if you will, because of the increasing complexity of energy and water systems around the world. And in fact, it's not just the big power grids, although power and electricity have, in many cases, led the way. We see it in water, we see it in gas, even in district heating, where data from connected sensors is now driving forms of predictive and autonomous operations.
Yeah. And Andy, specifically around that smart operations piece, what are you seeing as some of the kind of strongest, most relevant use cases for IoT?
So, not even historically. So, metering, of course, everybody has been always focused on metering, and we've got tens of millions of meters on our network, various forms already. What's undeniable, though, is that meters are becoming smarter, and the expectation of meters is increasing across all fuel types. People expect them to do more. They expect them to report more data. They expect them to be more secure. They expect them to be more reliable in terms of their connectivity, and they expect them to be able to exert some form of bidirectional control and be much more of a multifunctional sensor within the metered premises, domestic or commercial. So that's a growing trend. Of course, we've been doing smart meters. The industry has been doing smart meters for a number of years, and we've seen various technologies run through that. Where we're also seeing a lot of innovation, though, and some of it is linked to the meter, and some of it is being driven by non-traditional utility industries, is around the demand response area. And we are seeing that being pushed down from the traditional large dispatchable loads that you would normally have imagined demand response aggregators to be playing with, data centers, elevators, industrial machines, and things like that, to recently a number of entrants who are looking at providing and successfully providing demand response aggregation services into the domestic environment as well. And a lot of those guys are using cellular as their primary connectivity mechanism for doing that, especially in the regions where electrified heat is a large component of the built environment. So that's becoming really quite active. On the water side, apart from metering, I think almost every Western nation certainly has had a number of negative press events around wastewater discharge issues into the environment and the way in which we dispose of dirty water. And we're seeing a huge amount of sensorization and development activities take place, not only monitoring the wastewater treatment facilities on the part of the utility, but environmental agencies monitoring rivers, streams, canals, water courses, shellfish beds, coastal regions as well, to be able to detect, monitor, alarm, and remediate issues to do with untreated discharges as well. A lot of that links back to some of the environmental shifts that we're seeing and around population growth as well. A lot of the wastewater treatment plants that we've seen will be built for smaller populations than they are currently managing, and rainfall patterns have changed so that stormwater discharge, hydraulic overflow, is becoming more of an issue as well. Lots of activity in the IoT space and unapologetically the AI space around detecting and providing the ability to act on those sorts of situations too.
Amazing. Yeah. Again, another list of complications and things that we need to address. And
Yep.
to come to you, John, in that broader kind of IoT environment, particularly in utilities, connectivity is a fundamental. How have we seen that evolve in recent times? What is it, in terms of that role that Andy mentioned of cellular? How has that changed?
Yeah, so cellular connectivity for IoT has evolved quite a lot in recent years, and we now have quite a few different network technologies that are available and are really tailored to address different service requirements. So we have low power wide area network that can enable remote devices to operate on a battery charge for many years, and transmit data over that time with just a single charge. So that's one end of a spectrum, and then we have also 5G networks, which can deliver extremely high bandwidth, extremely low latency, very high reliability for mission critical applications. So there's a wide range. We also have networks that can support also remote coverage, but we have satellite backup and also satellite low Earth orbit satellite services that can support devices, not just as backup, but as the primary connection in some cases. So there's a wide range of services available. We also have managed connectivity platforms that orchestrate all of these connections and different networks. So this has been evolving quite nicely in recent years, and it makes it far easier for companies to deploy their IoT projects.
Yeah. And some of those kind of requirements, Andy, how does that relate to, if you bring in some of the examples of customers in terms of the various requirements and utilities, obviously reliability and things like latency. How are you addressing that in terms of that complexity?
I think it's really interesting and great to hear what John describing all of the different. I mean, I'm going to use the term RATs, radio access technologies, that we can service off the cellular platforms, 5G, 4G, 3G and 2G, obviously, they're end of life, or talking through, we're running through retirement programs for them with 4G and 5G as the primary bearers moving forward. But then you've got LTE-M/Cat-M and narrowband IoT as the LPWA platforms. And if I think about a manufacturer a number of years ago, they wanted to put an IoT device to market. They wanted to use cellular technology on it. The choice was easy, right? It was either 2G or 3G, move on. There was a small number of rats, probably a much smaller number of modems or modules that they could use for it, and a relatively constrained number of technologies that they could, not technology, protocols that they could use to run across that to exert control or read the sensors that they've got connected to the device. Now there's all of these all of these technologies, and my experience has been that actually you need a bit more expertise to be able to identify the right technology to target for your specific use case. Do you need lots of bandwidth? Does it need to be low latency? Actually, is this going into a deep, dark, or distant place, so you need extended coverage? Does it need to run on a battery? Not all of those questions are easily answered, but when we get engaged with manufacturers, hopefully at the early stage of a product development, we run through those kind of questions with them to try and tease out what the right target platform is for their device, and also run through questions about how their data is going to manifest. Is it going to be streaming? Is it going to be periodic? Is it going to be very, very bursty? Do they have a real hard requirement on low latency? And use that to home in on the specific RAT that is most appropriate for their use case. And then run through from there, having selected that or having identified that for them. Doing that early can actually avoid a lot of rework issues later on in the project when you find out that the system that you've chosen isn't necessarily the right one for your application.
Yeah. And Jean-Francois, I suppose the question is, have you seen within the utilities companies, excuse me, a change in attitude towards cellular IoT, or is it that simply the technologies become available and the requirements from on the utilities themselves is, meant that they've had to sort of embrace this and utilize it?
I think, well, we can start from the concept of fit for purpose IoT, where the basic consideration is really matching the connectivity solution to your operational needs or requirement. And as Andy was saying, utilities run a huge and growing variety of use cases. On the one hand, you have the mission critical equipment, like protection equipment or network automation that needs the millisecond type response times. On the other end of the spectrum, you have battery powered gas sensors in remote locations that need to last years. Or again, sensors buried underground in water systems. All these use cases generate substantially different connectivity requirements. I think the biggest change over the past 10 years is that cellular IoT is now fit for a much broader spectrum of utility use cases. Technologies like narrowband IoT, LTE-M are now mature and can meet the coverage, the reliability, and the cost requirements in a number of different contexts, be it urban, suburban, remote, rural, etc. We're also seeing utilities adopt private LTE networks at 450 megahertz, for example, which offers deep reach coverage and resilience for critical communications in countries where that band has been made available to utilities. And we've also seen big progress in manageability, I think. Utilities can now control and monitor millions, to the point that John was making, millions of endpoints through unified IoT connectivity platforms. That level of visibility and control simply wasn't there a decade ago.
So, John, what do you think is the secret sort of formula to unlock IoT value generally, but also specifically within utilities?
Yeah. Well, so utilities need to first of all evaluate what their service requirements are, and that really relates to their roadmap for the use cases. They need to consider what kinds of networks they will need to use, what kind of support they need from the service provider, if they need global coverage, if they need remote coverage. Do they need all of that in a single unified management platform? That's very common, and that's a very helpful functionality to aid in utilities in their management of their fleet. They also should think about what kind of analytics or automation they need in their IoT portfolios. Do they? Yeah, they should evaluate what analytics their service providers can offer, and whether that meets their needs. Security is another critical point, of course. That's always crucial, and particularly with the infrastructure that utilities are managing. That's a very important point to evaluate right from the start. And they should consider that when they're choosing their cellular services as well as the service provider. And there's other things to think about. They need to think about, does their service provider have industry expertise? Does the service provider know what utilities need and have experience working with utilities to deploy the solutions in secure and safe ways that fit their requirements?
Fantastic. And I'd bring the same question back to you, I think, Andy, as well. What do you think is the secret formula for unlocking IoT value?
Really interesting pair of answers there. Right? You may well have seen me making a couple of notes as you were talking. So I've written down a few bullets. So I'm going to throw in a few terms that might seem quite similar. I think there is a real focus within utilities and a real need to be able to guarantee essentially reach and resilience on their platforms. Okay, so they need to cover all of their customers or their endpoints wherever they need to get to, and they need to know that the connection that they're going to get is going to be resilient. And both of those are analog scales depending on the criticality of the application, but reach and resilience are really important. And from a network operator perspective, obviously you've got your cellular network, but IoT companies like Vodafone also have extensive roaming capabilities as well. So the IoT connectivity is able to roam typically across multiple operators in the territory that you're in. And we invest a lot of time and money in making sure that we've got a huge roaming capability in any territory that we operate within. Security and accreditation of that network, the whole end-to-end network up to the delivery point, is also key. And making sure that whoever is providing your IoT connectivity has got really robust and well audited and certificated security processes and certificates in place. Absolutely fundamental, especially in the energy sector. A platform, absolutely, but I don't think it's simple as saying, you've got to have a platform. Actually, and a large part of my background before I moved into IoT was about managing very large scale networks. Platforms that are actually built from the ground up to scale to the millions of connections that you were mentioning earlier on. Managing 10 connections is very, very different to managing 1 million connections, and the platforms need to be architected to do that from the outset. an analytics capability that lets you understand the behavior of your IoT devices, specifically around being able to identify outliers in that behavior set as well, and then maybe point yourself towards any emerging systemic issues that you have with the fleet of devices that's being operated. And finally, just going back to the reach piece, in any utilities always have a domain within which where they operate, a geographic area within which they operate, and you're going to have areas of very, very dense population and areas of very, very sparse population within those areas typically, and sparse areas are always going to be the areas that typically that are not only geographically remote but geographically troublesome as well. So they're folded, they're mountainous or hilly or right down on the coast behind a load of cliffs or something along those lines. And this is an area where we are really quite excited to look at some new opportunities for satellite IoT. There are a lot of satellite constellations up there that are being built now specifically for IoT services, GEO and LEO, and we're looking at mechanisms and avenues to integrate cellular with satellite onto our platform so that we can say, actually, within this area, all of your customers should be able to connect to our IoT platform, not just the ones who sit in well-covered areas, but the ones who are out on the edge as well, by taking advantage of some of those new satellite constellations that are being built right now. Final point, I promise I'll shut up, is expertise. You need domain expertise specifically within your IoT company who really understands the challenges that you're facing into, not just from a connectivity perspective, but what the devices are, what they're going to do, how they're going to talk, and what's going to happen with that information to be able to deliver the right level of service that you're expecting.
Fantastic. Thank you. And Jean-Francois, just to kind of almost give you the last point, what should utilities be focused on when they're choosing IoT connectivity providers? What are the key things they should look for?
Right. So my colleagues already said a lot, if not everything. So I can only probably reiterate some of the points. At the end of the day, utilities should look for more than just a network. We already said that utilities have been connecting assets for a very, very long time. They should look for a partner that understands the operational realities of this sector. Every sector thinks they are unique, but utilities is more unique than others, I think, having been in this industry for many years. So reliability, security, and scalability are the baseline at this point. What really differentiates a good IoT connectivity provider is, according to me, the ability to offer flexibility across technologies, transparency on connectivity performance, and I think long-term alignment with evolving industry and security standards. That's a critical piece. Utilities always frame technologies first and foremost in terms of safety and reliability first. And that's also why technology incubation or technology industrialization or standardization normally takes longer in this industry than in others. Because in utilities, and that's a very critical point, connectivity isn't a short-term service. It's a strategic asset. It's a strategic investment that needs to last for decades, 30, 40 years.
Fantastic. Brilliant. Thank you so much. I'm afraid we've run out of time, but it was great to, sort of to bring a lot of things together. It's been a really wonderful conversation. I think if I was to sum up what I've taken away from this is, yes, this is an incredibly complicated industry. both in terms of the factors and challenges facing it, but also just the footprint and distribution of the operations that it has to run. Smart ops is really central to that, and IoT is critical. And Jean-Francois, you made a very, very critical point there that, cellular as a piece of that is not an option or a short-term fix. It is absolutely central and critical to delivering those IoT capabilities. And Andy, I think you made a very critical point as well, that when it comes to something like this and the distribution and complexity of a utilities provider, the proof of concept to the scale up is very different to other industries. What works in the lab, what works potentially in a particular area is not necessarily going to scale up to the level of geographic complexity and even, rugged requirements that are placed upon it. So organizations have to think about and work with partners who are able to deliver on that. If you want to learn more about smart operations and IoT and utilities, please follow the links in the description below. We've got a very comprehensive IDC InfoBrief document that goes into a lot more detail on some of these areas and the specifics around key decision making, and also provides some insight on use cases and case studies and illustrations of where this has been deployed. And that just leaves me to say a big thank you to Jean-Francois and to John from IDC, and of course a very big thank you to Andy from Vodafone, and most important of all, a very big thank you to you for watching. Thank you and goodbye.